the relative max, just like this one is the relative minimum. Okay. Determine if the given critical point is a max, min, or a point of inflection. What is the shape of this one? This? It's a parabola, right? It's a quadratic. All right, so we'll either have a maximum or a minimum. Will it be relative or absolute? It should be absolute, right? Because it is a parabola. It's got one point where the graph turns. So we look at f of -1. We look a little bit to the left at -0.9. And we look a little bit to the right at -1.1. It's like in the back of some of your notes. No, it's today's notes, but it was like somehow it got put on the back. You didn't? Okay.
So only for when you're asking this type of questions when you set up the graph.
Well, and then also for continuity, you should have set it up if you're doing continuity, right?
Yeah.
Okay. All right. So at -1, I'm going to get 1 minus 2 minus 3, so I'm going to get -4. Correct? Is that what y'all got? What did you get at -0.9? -0.9 squared plus 2 times -0.9. No. 0.9. I bet you've plugged in 9. -3.99, and you'll get that same value here. All right, Rachel, you have issues with negative numbers. Is -3.99 greater than or less than -4? Yeah, so we're coming down from here and coming down on this side. Therefore, this is what kind of a critical point? What? I'm going down on either side. So I go down and then go back up if you want to look at it from that perspective. So let's talk about it again. What kind of critical point? Maximum. It's a maximum. And it's a, you're right. It's a minimum. That's what I said. It's a minimum. And it's an absolute min. Depends on the shape of the graph, right? When the tails go up and down, both, then it just kind of depends on what we're looking at. Okay? Excuse me. Okay. All right, so here we go. This is 3-7. So, Emily, do you have anything to use to take? You've got a stylus now? Okay. All right, we're talking about asymptotes, and we're going to talk about the rational function. This is the parent function 1 over x. All right? We want to look, right now, we know where to figure out a vertical asymptote. Where do we figure out the vertical asymptote? Where do we look for that? Our vertical asymptote is x values. And where do we look to figure out what values x cannot equal? In the denominator, okay? So in this case, this is your shift. This is what it's going to look like. It's what are we adding or subtracting down here and over to the side. That's how we change the parent function 1 over x so that we can figure out our asymptotes. So in this case, x cannot equal 0, correct? Which is our vertical asymptote. And this value right here gives us our horizontal. Your options for asymptotes are either going to be a vertical asymptote, a horizontal asymptote, or a slant asymptote. You always check for this one, and then you have a choice of either the horizontal or the slant. Never will you have both the horizontal and the slant. It's either one or the other for these rational functions. Because that's what x can't equal. This is where we determine our vertical one at. At y equals 5, you'd have a horizontal. Okay? And we did this last year. We did some of this graphing, at least in my class we did. All right. We know in our mind where the parent function, where we're graphing if it's positive. Usually it's in the first and the third quadrant. Okay, if you remember, the parent function looks something like this. This is what a rational function looks like. On the first couple days of this chapter, we talked about parent functions and what do they look like, and then we talked about shifting. Okay, so look at this problem. Y equals 2 over x plus 3. I need a horizontal asymptote, a vertical asymptote, and a slant asymptote. Okay, horizontal asymptote. What is my horizontal? Why are you saying 0? Okay, horizontal is the number to the side, right? Right? Here's where we find the horizontal asymptote, out here to the side, right? So we want to look at this as y equals 2 over x plus 3, if there's nothing there right now, plus 0. All right, so what's equal to 0? We want to write it as an equation. If it's horizontal, and it's, what do we say? Is that x equals or y equals? Y equals. Y equals 0. What's our vertical asymptote? What x value can't exist? So we write x equals negative 3. Don't just give me negative 3 as my answer. I want it as x equals negative 3. Okay, if we have a horizontal, we don't have a slant. Okay. Depends on how it's presented to you, and I'll show it to you in a second. Okay? So, a horizontal at 0 means that's the x-axis. A vertical at negative 3 means right here. Okay? All right, so let's see where our graph is going to fall by doing some test points. Look at your vertical asymptote. Pick a value to the right of that and pick a value to the left. In our mind, we know that it's probably going to be here and here because we haven't reflected or done anything to it. We don't have a negative sign. All right? So a value to the left might be negative 2 for x, and a value to the right might be negative 4 for x. At negative 2, I'm going to get 2 over 1, which is 2. So I know that this is what my graph is looking like on that side of my vertical asymptote. Because he's a rational function, and all rational functions behave in the same way. And at negative 4, I'm going to get 2 over negative 1, which is negative 2. So I'm over here. And so I know that I'm in this portion between these two asymptotes. Only to find what? And you go to the left and to the right of that vertical asymptote and see where you're figuring where your figure is going to fall. Okay? Kind of a review from last year. All right, this portion. All right, horizontal asymptotes. There is another thing that you have to consider in a horizontal asymptote. When you have a single fraction, so a single fraction and the degree, let me get rid of this. And the degree of the numerator and denominator are the same. The horizontal asymptote is the lead coefficient of the numerator divided by the, okay, what does that mean? Yeah, exactly. There's a lot of words. Okay. So when I have a single fraction, and I have a variable in the numerator and a variable in the denominator, look at these ones over here. These ones had a variable just in the denominator, correct? So we looked out to the side to figure out where that horizontal asymptote is. But look at this one over here. See how there's a variable in the numerator and in the denominator? So when the degree of the variable on the numerator is the same as the degree of the denominator, we have a horizontal asymptote where we look at just the coefficients. We look at this and this. We ignore the 1 for the horizontal asymptote. Okay? And we say y equals 2x over x. We're just wanting to really look at the coefficients because aren't the x's going to drop out? X over x's drops out, right? So that means our horizontal asymptote is at y equals 2. Because it's 2 over 1, which is 2. So when you have a single fraction, again, and variables appear in the numerator and in the denominator, and the degrees of both are the same, that's how you determine your horizontal asymptote. Okay?
What if it's like a plus 3 to the side?
Doesn't matter. I just want the coefficients of that term that has the x of the highest degree. Okay? All right, so this is my horizontal. What would be my vertical? X equals negative 1. Exactly. So x equals negative 1 is here. Y equals 2 is here. It's what makes your denominator 0. We look at our denominators to determine vertical asymptotes. Yeah, well, doesn't it make sense? You're going to a y value. Okay. All right, and so doing our little test point, we always choose a value to the left of our vertical and to the right of our vertical. So maybe I'll use 0 and I'll use negative 2. So at 0, I'm going to get 0 over 1, which is 0. And at negative 2, I'm going to get negative 4 over negative 1, which is 4. So at 0, I am at 0. And at negative 2, I'm at positive 4. Does that make sense? Anybody got a question? Okay. What makes this one that I just did different from this one? It has only one variable. So how do I find my horizontal asymptote if there isn't a variable in the numerator and the denominator with the same exponent? It's the value that's added or subtracted. Do you see the difference between these two rational functions? Okay? So here, my horizontal asymptote is at y equals what? And it's this 2 right here. And my vertical asymptote is at what? What's 2? X equals 2. I will, even if you graph this right, take off if you're just telling me that it's a number. I want it as an equation. So do your little test point. All right, if x is going to equal 1 and 3, those would be some good values to use for my x. If x is 1, I'm going to get 8. Is that right? I'm going to get negative 4, aren't I? Is that right? Which tells me I'm doing this. And at 3, I'm going to get 8. Okay? All right, then we have one other kind of asymptote. And that's a slant asymptote. What do you know about the rational functions now? Look at the way they're drawn or written out. And the degree is how much larger? 1. Exactly 1. Can only be 1 greater. This degree is 3. This degree is 2. This degree is 3. This degree is this exactly 1 greater? So this has no slant. Okay? All right, so what is my slant asymptote? So the way we figure out the slant asymptote is we divide. X squared divided into the numerator, x cubed plus 1. Now remember, when we are doing long division, every term has to be accounted for. You did this last year, and then we did synthetic division last year too, remember? We talked about long division. So this is like 0x squared plus 0x plus 1. Remember, every term has to be accounted for. If all I have is x cubed plus 1, I'm missing the x squared term and the x to the first term. I may need them, I might not. Okay? All right, and what are we dividing it by x squared? Well, how many times does x squared go into x cubed? Once. I'm going to put this over the x term. Well, because remember, whenever we do dividing 3 into 16, we don't put it over the 1, do we? We put it over the term that we're using. No, we're not. We're using the x. We're going all the way to the x term. How many times? How do we get x cubed? X squared times what? X. Is that better? All right, so I'm going to get x cubed. And what do we do when we divide? We subtract, don't we? We subtract every term, however many terms there are. In this case, there's just 1. And if we've done it right, the first term should drop out. It doesn't do me any good to bring down these 0x's, but I can bring down a 1. So x squared times what is 1? Well, that's your remainder, isn't it? Because there's nothing that you're going to take x squared by to get 1, correct? So this is your remainder. And when you're doing slant asymptotes, you ignore the remainder. You ignore it. And so the equation that you use for graphing purposes is the equation y equals x. All right. Yep. All right. This is y equals x. If I have a slant, do I have a horizontal? No. But do I have a vertical? What's my vertical? At 0. What's 0? Nope. X equals 0 is your vertical asymptote. Okay. Can you see that we've got 4 sections in which to look at? They're always across from each other, like vertical angles. I can either pick here and here, right? Or I can pick the wide parts. But they're defined by the asymptotes, not anymore by the x and the y-axis. Do you see that? Okay, so we do our little x-y chart. And we'll look at a little bit to the right of our vertical and a little bit to the left of our vertical to see where we're falling. Yeah, at y equals 0, or x equals 0. So at 1, I'm going to get 2. And at negative 1, I'm going to get 0. Did I do something wrong? At negative 1. Oh, no. Negative 1, I get 0. No, negative 1, I get... At 1, I get 2. And at negative 1, oh, I get 0. But that doesn't work. Because it is... No, it's 0 on the top is okay. But not on the bottom. But negative 1 on the bottom is positive 1. No, we're not doing that one. Okay, let's try another value just so we know. So where is 1, 2? 1, 2 is right in here. At -1, I got 0. I did something wrong on this problem. Well, no, at -1, 0, it's right here. But that's telling me I'm doing this. And that doesn't make sense.
Why does it have to be the other triangle?
Generally, they're across from each other. Let me see what happens when I use... Let me see what happens when I use -2. That's -7/4. -2 and -4. Yeah. I did something wrong. How do I know? Because I can't have 0 in my denominator, right? Because we look at our denominator. Yeah. I tried -2, and -2 works. All right. This is what? There is a lot. Okay, try the following. Find all the asymptotes. What is my horizontal? Because we're going to look right here. What is my, do I have a vertical or a slant? Do I have a slant? Because I have a horizontal, I won't have a slant. What's my vertical? X equals 3. Okay. What about this one? What's my vertical? Ah. Ah. Thank you. Do I have a slant? Do I have a horizontal? Y equals 0. It's this number out to the side. Because the numerator's exponent has to be 1 greater than the denominators. All right, let's look at this one. This one's tricky. Cool. But not the top. No slant. Because the top has to be 1 greater than the bottom, not the bottom being 1 greater than the top. Okay, there's something funny that's going to happen in this case. Isn't this the same as x plus 2 over x plus 2 and x minus 2? Well, we don't ignore it. But doesn't this reduce down to 1 over x minus 2? Sometimes you do. You do. If it's factorable. But I want you to know, initially, what could x not equal? Because remember, this is about domains. And -2. X can't equal 2 or -2. If there's ever a place where your function doesn't exist, at any point you have to state that because it does affect how it looks. Now, can I use -2 in my final, my simplified function? Yeah, I can use -2 here. -2 is fine. What doesn't work down here? So that means x can't equal -2 is going to be what kind of an asymptote? A vertical asymptote. And will I have a slant or a horizontal? +2, thank you. I'll have a horizontal, which means it's what? Y equals 0, and there's no slant. Okay, but we still have to recognize that this value of -2 is not okay. And what happens then, since it cancels out, is that we get something called a hole, or a point of discontinuity. You have a what? Is the whole. Because remember, if it's ever a problem in the problem, we have to recognize it. So I need to finish this, so even if the bell rings, I want you to stay. We have a vertical asymptote at 2 and a horizontal asymptote at 0. And at x equals -2, we have a hole. That's our test point for that region. At -2, I'm going to plug it in to this function right here. At -2, what is my y? -1/4. So at -2, I plugged it in right here. Because I need to know that y value that's associated with this funny thing that's going on with x. So at -2, I have -1/4. It's a hole. It's a point of discontinuity. And then we know that it's going to do this over here. Because it canceled out. Because if we cancel it out, it becomes a hole. Okay? And then we would try another one like 3. When x is 3, I get 1. Everything over here is okay. You always use the simplified function. The hole was created here, and we come up with this function that we're graphing.